Hello everybody, my name is Nicole and today I will be teaching you how to go through the problems of stoichiometry. So today's reactants are going to be zinc nitrate and barium hydroxide. In solving stoichiometry problems, you need to first start out with your equation. So we're going to start off with our reactants, which are zinc nitrate. Nitrate is actually one of your polyatomics. And zinc nitrate is going to have a +2 charge according to the periodic table, which is a constant thing. So you're going to put a subscript over here with nitrate once you flip the charges. With barium hydroxide, which is what it reacts with, is Ba for barium. And hydroxide is another one of your polyatomics, so we're going to go ahead and put OH in parentheses. And we are going to know that barium has a +2 charge, and so over here with hydroxide it's going to gain a little 2 subscript. Okay, so you have your two reactants in equation form. So now we're going to go to the reaction. In this, you have zinc and barium, which are two metals, so they're going to end up replacing each other, which is called double replacement. And this is a type of reaction. So zinc is going to go in the place of barium. So it's going to now be zinc hydroxide. Again, zinc has a +2 charge and it's going to help hydroxide gain a subscript of 2. And our next one is going to be barium nitrate. Again, barium has a +2 charge and is going to put nitrate to have a 2 subscript. Okay? So you have your equation here, and it is balanced. Now when I say balanced, I mean that each element has the same number of itself in each side, in the reactant side and the product side. I'll show you. So we want to first start off with zinc. On the reactant side, we only have 1, and on the product side, we also have 1. There's no coefficient or subscripts to change the amount. Our next element is nitrogen. Over here, we have a subscript outside of the parentheses, so that would infer that nitrogen is going to gain 2 of itself. On this side, you have the same idea. 2 is going to go to an N over here, and it's going to make nitrogen have 2 of itself. Our next element is oxygen, and as you can see, it already had a 3 subscript, but when it's outside of the parentheses, you're going to multiply the 2, and it's going to become 6 oxygens. And over here with barium, which is your other reactant, is going to also gain a 2 from the subscript, so that is going to be 8. 6 plus 2 would give you 8 oxygens total. Over here, we have the same exact thing. The 2 is going to go over to the oxygen, and the 3 is going to multiply with the 2 from the outside and give it 6 oxygens. So that 6 plus 2 is 8. Barium over here on this side has only 1, and same goes over here. So you're good with that one. Hydrogen is our last one. It's also going to gain a 2. So over here we have 2 hydrogens, and over here our 2 is going to go over 2 as well, and it is 2. So our equation is balanced, and we did not have to do any work of any sort to try to get it to be balanced. But I will tell you that that is a very important step, because if it's not balanced, you're going to need that later in the problems we are going to do soon. Okay, so the second part of our equation is going to be finding the molar masses of each compound. So I've already done the calculations, but the way that you can find the molar mass is going to each element and looking at the periodic table and what their atomic mass is. And once you have added all of them, that is going to be your total. So zinc in here on the periodic table is 65.38. So that is going to be Okay. So the second step in your equation is going to be finding out the molar masses for them. So I've done the calculations already, and zinc nitrate has 189.388 grams. That is the molar mass of zinc nitrate. And you can find the molar mass by looking on the periodic table and adding up all of the atomic masses of each element. So you would add 1 zinc, 2 nitrogens because of the subscript, and 6 oxygens together, and you will get this answer. For barium hydroxide, we have 155.343 grams. So that has been completed. And so on our product side, zinc hydroxide is going to be 83.395 grams plus barium nitrate, which is 261.366 grams. So once you have all of your molar masses, you are going to be using this for the rest of the problems that we are going to do later. So my first lesson today is going to be going from mole to mole conversions. So I'm going to pick one of my reactants, zinc nitrate, and I'm going to put 11.03 moles of zinc nitrate. It's very important that you label what and how many moles you have of a certain compound. So that's going to be my first part of my chart. And when I was talking about balancing, it's very important that you have balancing because you are going to have coefficients if it was needed to be balanced. But in this case, all of our compounds are going to have a 1 in front of them. So 11.03 moles of zinc nitrate is going to be 1 mole of zinc nitrate. Again, I got the 1 mole from our coefficient, which it's not there, but you know that if you didn't have at least 1 of zinc nitrate, then it would not be there. So our 1's going to come over to here, and I want to go from zinc nitrate to zinc hydroxide. So what I'm going to do is look at the coefficient over here on zinc hydroxide, and I'm going to see that there is a 1 there as well. So I'm going to have 1 mole of zinc hydroxide. And when solving for this, you are going to multiply across the top and divide by the bottom, and you will end up getting 11.03 moles of zinc hydroxide. It was very simple. We just multiplied 11.03 times 1 divided by 1, and it would be itself. So your answer here is 11.03 moles of zinc hydroxide. Very simple, but if the situation were different and say zinc nitrate had a 3 coefficient in front of it, you would multiply 11.03 mole times 1 and you would divide by 3 instead of 1. But that's not in this case, so we are just going to continue. My second way that I'm going to show you to solve a stoichiometry problem is from grams to grams. So I'm going to pick one of my reactants, barium hydroxide, and I'm going to pick the number of my choosing, 1103 grams of barium hydroxide. And I want to convert it to whatever many grams of zinc hydroxide. So for this, we are going to need our molar mass. So to mark out the number of grams, we're going to need the number of grams in barium hydroxide as a molar mass. So you have 155.343. 343 grams of barium hydroxide. And above this, you're going to put it equivalent to 1 mole because 1 mole is always equivalent to the molar mass of your compound. So these two have been canceled out. So what we're going to cancel out next are number of moles, and you're always going to set it to 1 mole as well. We got the 1 mole from this side, again from our coefficients in front of barium hydroxide, which is 1. And we're going to take the number of moles from zinc hydroxide, which is 1 mole. And these have been canceled out. Okay, so now we are going to try to cancel out the 1 mole of zinc hydroxide, and we are going to put it equivalent to 1 mole of zinc hydroxide. And in order for me to want to cancel out the moles of zinc hydroxide, I'm going to put the atomic mass of zinc hydroxide equivalent to 1 mole, which is always, it's 83.395 grams of zinc hydroxide. And once you have finished this, you have all of your things in the chart. So you're going to multiply 1103 times 83.395 and divide by 155.343, and you will end up getting 5.921 grams, and you're going to be left with zinc hydroxide. And that is how you find grams. And so we went from 11.03 grams of barium hydroxide to 5.921 grams of zinc hydroxide. So you are done with the mole to mole and gram to gram conversions. Our next lesson is going to be our limiting and excess reactant. So what that means is that we are going to see what reactant is going to have an excess amount and which has a limited amount. So what we want to do is go to one of our products. In order to compare, you need to have the same product. So I'm going to pick zinc hydroxide, and we are going to go from gram to gram, from zinc nitrate to zinc hydroxide, and then our second chart will be from barium hydroxide to zinc hydroxide. So let me do the first one really quickly. So I am going to have, I'm going to pick a number, and I'm going to put 5.25 grams of, zinc nitrate. That's going to be the first part of my chart, and I'm going to put its molar mass, which is going to be 189.388 grams of, again, zinc nitrate. And I'm going to set it equivalent to 1 mole of zinc nitrate. And this is going to, again, be equivalent to 1 mole of zinc nitrate. And then, since we're going to zinc hydroxide, we are going to put 1 mole of zinc hydroxide. And that's always going to be equivalent to 1 mole of, again, zinc hydroxide. And then we are going to put the atomic mass of zinc hydroxide once again, 83.395 grams of zinc hydroxide. Okay, so we are going to multiply across the top and divide by the bottom. And what we are going to get is 2.31 grams of zinc hydroxide. Okay, so we're going to keep that in mind, all right? We are not going to go from barium hydroxide to zinc hydroxide. So our next equation is going to start with, I'm going to pick a random number. We are going to start with 12.18 grams of barium hydroxide. Okay? And the molar mass of barium hydroxide is going to be 155.343 grams of barium hydroxide. And that is going to be equivalent to 1 mole of barium hydroxide. And And that, again, is going to be equivalent always to 1 mole. And since we want to go to zinc hydroxide, we are going to also put 1 mole of zinc hydroxide. Again, it's going to be equivalent to 1 mole of zinc hydroxide. And our molar mass of zinc hydroxide is going to be 83.395 grams of zinc hydroxide. And again, we are going to multiply across the top and divide by the bottom. And what you are going to get is 6.485 grams of zinc hydroxide. So once you have found the number of grams of zinc hydroxide from each reactant, you're going to see that one amount is less than the other. The amount that has the less amount of grams, which in our case is 2.31 grams, the starting reactant is going to be our limited reactant because there is not as much as the other reactant. So zinc nitrate is going to be our limited reactant. Alright? And over here, since barium hydroxide ended up with a bigger amount of grams of zinc hydroxide, this is going to be our excess reactant. So it really depends on the ending product that you get. And what is the less one? The lesser one is going to be your limiting reactant. And the one that has the greater amount of that is going to be your excess reactant once again. So my next part is going to be our theoretical yield and our percent yield. Our theoretical yield is basically what we got from the equation that is supposed to happen. But we need to know the actual percent of how true we have gotten that. So I have been given the true amount of 2.31 grams of zinc hydroxide. And I'm going to do it down here. There's not a lot of room, but I'll make it work. I'm going to find the percent yield. And our theoretical yield is 2.31 grams of zinc hydroxide. And again, in theoretical yield, you're going to use the one with the lesser amount. So in finding the percent yield, you're going to do the actual amount over the theoretical amount. So I have been given the actual amount, which is 2.29 grams over our theoretical yield, which is 2.31. Okay? So once you divide that, you're going to multiply it times 100 to get the percent, and it is going to be 99.1%. And that is how you find your percent yield. So each step really follows into the next. When you go from mole to mole, you're going to go to a bigger step and do mass to mass. And then that's how you can end up finding your theoretical yield and your percent yield. Alright? Yeah. Okay, so I have barium hydroxide and zinc nitrate. So let's see what happens. Whoa. It turned really foggy and has like little solid particles in it. And yeah. There's no temperature change. It just formed a precipitate.
And barium hydroxide.
That is what happened.